Hello, hello, hello. Welcome to another episode of Not Your Average Maths. Today we're going to be doing something slightly different. All right, so I'm looking at this question. A 250 kVA, three-phase delta star connected step-down transformer has a phase turns ratio of 287 to 1. The primary is connected to a 66 kilovolt three-phase supply and the transformer is fully loaded. Calculate the secondary phase voltage. Now, when I'm doing these questions, the main thing that I'm going to be thinking about is I'm going to have I've got these two equations here. Power equals square root of 3 VL IL cosine theta. Now, with this equation, because it's a transformer, I don't actually need to worry about the cosine theta part. So I'm just going to remove that. So I've got that equation, and then I've got this equation here. These are the two equations that I'm going to be using most of the time with the transformers questions. I'm also going to be using this one. So they're kind of the four equations that I'm going to be using. These ones here are for when I have phase and I'm converting to line, or when I have line and I'm converting to phase. All right, this one here gives me the phase voltage or phase current, and this one gives me line current and line voltage. The L there means line. So those are the equations that I'm going to be using mostly. All right. With that in mind, I want to find the secondary phase voltage. First thing I'm going to do is make a list of what I have. So I know that power is 250 kVA. So that means that it's going to be 250,000 VA. All right, I've just converted from kilo to regular, so kilovolts volt amps to regular volt amps. And multiplying by 1,000. Then I have that the number of turns, the ratio is N1 over the ratio N1 over N2 equals 287 over 1. I also have that the primary, so V1 is 66 kV, which I can then convert to volts by multiplying by 1,000. I also know that it's three-phase supply. If it's three-phase supply, I cannot use my voltage, resistance, current, power wheel. Cannot. All right. So I want to find the secondary phase voltage. I'm kind of looking at this equation here because I've got the ratio and I've got one V and I need to find the other V. This one here I can't use the power equation because I don't have current yet. All right, so I'm going to go N1 over N2 equals V1 over V2. So that's 287 over 1 equals V1, which is 66,000 over V2. Now, in order to solve this, I'm going to switch these two. So that's going to give me V2 equals 66,000 over 287. Now, some of you might be wondering how I could switch those two, and some of you will be pretty happy with the fact that I can. So if you're happy with the fact that I can, skip ahead and we'll look at finding the next part of the equation. But if you want to find out how I rearrange that equation, stick around. So I've got this equation here. I'm going to look at this one here. And so I've got 287 over 1 equals 66,000 over V2. Now, in order to, what I want is I want to end up with an equation that has V2 equals a blah, blah, blah. The way I'm going to do that is by multiplying both sides by V2. Now, in maths and algebra, I can do anything I want as long as I do the same thing to both sides. So in this case, if I multiply this side by V2, I've got a times V2 and a divided by V2, which gives me V2 divided by V2. And now logic tells us, we know that if we have 3 over 3, that's going to equal 1. If we have 17 over 17, that equals 1. So we can extend that to say that this is going to equal 1, which can then mean that that and that is going to cancel out. Now that's going to be quite convenient for us. So now I have V2 times 287 equals 66,000. Now, I've currently got times 287. What I'm going to do is divide that, and as we discussed, excuse me, as we discussed, a number divided by itself equals 1, so that's going to cancel that out. Now, I have to do the same thing on both sides, so I'm doing it down here as well. And that is how I got this guy. Now, there is one other way. So if you're happy with that, again, skip ahead. If not, I'll show you a different way of doing it. That's going to give you the same result. So here, I've currently got, on the side, I've currently got divided by V2. So in order to rearrange an equation, I'm going to do the opposite on the other side. So if I've got divided by V2, that means I'm going to do times V2. So it's going to give me 287 V2 equals 66,000. Now again, opposite on the other side. I've got V2 times 287. So I'm going to divide by 287. All right. Hopefully that made sense. Of those 3 methods, it does not matter which one you use. All right. Good to see you back. What I'm now going to do, excuse me, is I'm going to divide. So I've got 66,000 divided by 287. So that gives me a secondary phase voltage, V2 equals 229.965, and so on. So that's going to give me a nice V2 of 230 volts. All right. Now, the question is asking me to find the secondary phase voltage. Now, this here equation always gives it to me in phase. So that tells me that this phase, V2, is secondary phase, which means I have answered the question. All right, just clearing the space for us. So I'm going to put a V equals 230 volts. Now, I need to find the secondary line voltage. So secondary tells me that it is star. And I have this equation here, which tells me that V phase equals V line divided by square root of 3. Now, the reason I'm going to choose that equation is I have the secondary phase voltage, and now I need to find the secondary line voltage. So I'm going to fill in my... I'm going to fill in the equation with what I already know. So V phase is 230 equals VL divided by square root 3. Now again, I'm going to use algebra to rearrange the equation. I can either multiply by square root of 3 here, so the opposite. So I've got divided by square root of 3. I'm going to do the opposite, and I have to do the same on both sides. Or I can do the opposite on the other side right here. So if I do the opposite on the other side, I've currently got divided by square root 3. I'm going to multiply by square root 3. Now, I know that square root of 3 is about 1.73. So I can use that approximation if I want, or I can just do it on my calculator. 230 times square root of 3 equals 398.37, which is approximately 400 volts. All right. Hopefully that's making sense so far. Again, I'm just going to clear some space so we can go on to the next part of the question. So V2 line equals around about 400 volts. All right, calculate the primary line current. Now, with this one, these are my two main equations. I can't use the second one because I don't have the secondary current. So I'm going to use this equation here. And again, this is going to be quite convenient because I want line current and this is line. So primary, I'm going to use this voltage here. Because if you look at the formula sheet, you'll see in the delta section, V phase equals V line. So that means that I can use this voltage as either a line or a phase. So I've got power equals square root 3 VL IL. Now I know that my power is 250,000. And I know that my voltage is 66,000. Now I like to put the commas and the units in. You don't have to. All right, now again, we're going to do the opposite on the other side to move these across. So the way I'm going to do that is by dividing. Now I'm going to put all of that into my calculator. Now I'm going to put brackets around this and do square root of 3 times 66,000. But if you wanted to, you're welcome to go square root of 3 times 66,000 and then 250,000 divided by that number. It's absolutely okay to do the extra steps because you want to make sure that it's correct. Now I've multiplied that out and divided it, and I get an IL, or primary line current of 2.19 amps. All right, we're nearly there. Just again, making space. I line. And I'm going to do I1 line. Equals 2.19 amps. All right, the secondary line current. There are a couple of ways I could do this. The way that I'm probably going to do it is using secondary line voltage and the power equation. I could also convert this to I phase, then use this equation here, and then convert what I get back. Let's try it both ways. It's really up to you which way you do it. Let's start by converting this. So this is primary I line. So I want to find I phase. Now I'm using the delta equation because it's a delta star and primary is delta. IL divided by 3, which would equal 2.19 divided by square root of 3, which equals 1.26 amps. Now I'm going to use this formula here, and I can actually choose whether I use the number of turns or the voltage part. I'm going to use number of turns. So 287 over 1 equals I2 over 1.26 amps. Now again, I'm going to do the opposite on the other side, which means I'm going to multiply by 1.26 amps, which should give me 362.88, or approximately 363 amps. All right, we're now going to redo now. That would be I phase, secondary phase. Now it's star connected. The secondary is in the star connection, and I know that I line, the line current equals the phase current. IL equals I phase in star, which means that my final answer is 363. All right, now let's do it the other way. So now I'm going to use the power equation. Now remember that either way is absolutely fine. And it's just up to you which one you prefer. A lot of people tend to be more comfortable with this equation, but remember your extra steps. So now I'm going to fill in the equation. Power equals square root of 3 VL IL. Just moving my pen box so I've got room. And now this is a secondary, so I'm going to use this voltage. And I'm choosing this voltage instead of this one because it says line. And that L there reminds me I need a line. Times IL. Now again, I'm going to rearrange it, do the opposite on the other side. Equals IL. Now again, when I'm calculating it, I'm going to put it in as times 400. And I'm going to put brackets around that. Divided by bracket square root 3 times 400. And that gives me an IL line current of 360.84, which I'm going to approximate as IL approximately equals 361 amps. Slightly different to what we had earlier. All right. I just wanted to check. I can't find my other answer. So when I did it previously, we got 362.88. That is not a significant difference. And what you'll probably find is that the multiple choice answer you'll get offered will be in the ballpark of 360, 362. I don't think, I would not expect them to give you options for 360 and 362. Again, I can't guarantee because I'm not the one providing the exams, but that should give you either way, you should be fine. All right. Thanks heaps for joining me today while we looked at a question from the EWRB exams. Good luck. Message me if you've got any questions or suggestions for further content. Don't forget to like, follow, and subscribe. See you next time. Try not to increase or decrease the population in the meantime.